The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is Jeff Garbus, and I am here to host our second day of database-related discussions. We have two topics for today. The two topics are performance and master data management. For those of you who are going to be attending all three of these sessions, you will be entered into a drawing for a 4-night stay in a luxury cabin in northern Georgia. That is up in the Blue Ridge, Georgia area. Beautiful area any time of year. I highly recommend giving it a shot, whether you win it or not. My name is Jeff Garbus. I'm the CEO of Soaring Eagle Consulting. We are a database managed service and database consulting company. We've been in business for over 20 years, and with luck, we'll be in business for another 20. About 60-70% of our business is database managed services, about 20 to 30 consulting, and depending on the day or year, we do a little bit of resales of software and hardware. Something we do as a service for our customers, not necessarily something that we spend a lot of time going after. We're far more interested in making sure that all of our customers are taken care of. So let's talk a little bit about performance. One of the things that we've seen over the years, and by over the years, I'm going back more than 30. I was certified to teach performance and tuning back in the late 80s, and that was back when you actually had to have done it before they would let you teach it. Things are a little bit different today. Anyway, I've also spent a lot of time working with hardware vendors because what ends up happening is people like throwing hardware at performance problems. Why is that? Well, the hardware is not necessarily cheap, but it's an easy solution. It's an easy solution because if you want to try to take the time to uncover root cause, then by the time you've identified the root cause and tested it and proven it and rolled it out, sometimes you get a good 6 to 8 weeks of elapsed time rather than fixing things immediately, whereas there really isn't a lot of testing involved simply to roll extra hardware in, more CPUs, more memory, faster disk. So I used to get called in a lot by third-party vendors saying, Jeff, I just spent $3 million, or Jeff, we just sold $3 million worth of hardware. Do me a favor and figure out how to make us not look silly for it not having any effect. So let's talk about performance. In the beginning, we start out with defining performance. What is performance? How do we define performance? About 20 to 30% of my time is dedicated to resolving issues that people say are performance problems. So sometimes it's, well, our web users are experiencing multiple seconds of wait time before they see an answer. Sometimes it's, well, we can't quite figure out how to fit our 20 hours of batch into our 8-hour window. And sometimes it's anywhere in between. Sometimes folks don't look at user complaints. Instead, they look at resources. Are we above capacity on CPU, disk, network, etc.? So when I get brought in, people have identified we have a performance problem and they say fix it. And I always ask, well, what is it that defines your performance problem? What is it that got you bringing me in? Now, a lot of the organizations that bring us in have dedicated rooms to letting people yell at each other over performance problems. They often call it a war room, and what happens frequently is something along these lines. The business unit owners come in and they say, I can't handle 3 to 5 second response time, an occasional 20-second wait time, all these things are going on. The groups in this room include development, database, network, storage, CPUs, hardware. Generally, everybody in the entire IT arena gets invited to the talk. From the invitation to the talk, the developers say it's the database. The database people say the database is performing fine. the network seems to be slow, or the storage seems to be slow. And the network people can always demonstrate that their network throughput is only at 3% of capacity, and the storage people are saying everything is only at 2% of capacity. And the developers are saying, hey, it runs fine in test, and the database folks are saying, well, it's not running fine in production. So you end up with a finger pointing, and this is generally where we get called in. The fingers are getting pointed. There aren't really any winners there. Nobody has been able to demonstrably prove their case. You may have already thrown some hardware at the problem first. The hardware is not resolving it, and yet there's an issue to be resolved. Now, one of the reasons this happens a lot in large organizations is just raw numbers. Trying to figure out where to get the performance problem fixed is pretty high. The numbers that we have on this screen, I did not make these up. These come from a variety of sources: Gartner Group, Forrester Group, internal Microsoft numbers. I say internal Microsoft numbers, I really mean numbers that Microsoft has shared with its customers based on its own internal findings. So running through these, it is a long time and a lot of telephone calls just identifying the right person to identify performance issues. The second number and the final number tie together pretty well. This number that IT spends almost a quarter of its time on performance-related issues really points to the fact that you have a lot of activity circling around making sure that the data that you want to bring out is in fact effective. This is also exacerbated by the fact that those of you who do take the time to purchase and use load testing equipment might be wasting some of your time. If you take a load testing person, that is to say a person who works for a load testing company, out for a beer and buy them a couple, after they've had a couple beers, they will admit that their load testing tool is likely to get 30% of your performance issues. I've met a lot of very experienced CIOs, as in large companies and decades of experience, who don't bother with the load testing tools. They say, you know what? I'm going to put this in my load testing environment, have everybody hit enter at once and see what happens. It may or may not be a better way of approaching it, but a lot of people whose opinion I respect think that's the way to do it. The 70 number, I'm not sure I agree with. 70% of performance problems are caused by source code, not infrastructure. Now, if you stretch that source code to include other types of software-related infrastructure, then I do agree, because we can use indexes to resolve a lot of the problems that are registering or occurring at the end user level. And this is something that I do literally every single day. 73% of problems first reported by business users. I would have expected that number to be higher. And the last one, 80% of the mean time to resolution is spent getting to the root cause of the problem. I would expect that in real life that's higher. But if you take that 80% number and combine it with that 24% number higher up, what we find is that if we can get to the root cause of our problem immediately, you get a fifth of your staff back. Or said another way, you become 20% more efficient because now you've eliminated 20% of the time you spend on those performance-related issues. Those of you who are in IT, which is everybody on this call, are probably familiar. I just saw a question, what is the number of days it takes to identify the problem? It depends what kind of tools you're using. With a good tool, you can identify it almost immediately and keep that down to a single day. Every once in a while, you watch a movie and you have one of these aha moments. Something just sort of clicks. That clicking occurred to me. I was watching a movie called Row House, oh gosh, a couple decades ago now. And Patrick Swayze said, it's no worse than we're used to, but it's pretty insane what we've gotten used to. And this defines the creeping commitment that we've seen with applications. I'll give you a very specific example. I was working with a very, very large media company a few years back. And they said, hey, Jeff, could you take a look at this? This job is running in about 6 hours. And it's okay right now because we've got an 8-hour window, but when we first started running it, it was a 20-minute job. And this is that sort of creeping commitment. Over the course of years, it's gone from 20 minutes to 6 hours. They've identified that there is a boundary that they're going to hit, and they need to resolve the performance issue before they hit the boundary. So my suggestion is when people start complaining is the time to start resolving, as opposed to when the complaints start to get a little bit nuts. The 2 case studies listed here from real life examples of problems that we went in to resolve. One was an e-commerce company that was getting 9-second response time on its queries. Now, I personally have the patience of a 2-year-old, which means that if I'm not getting response time from my web app, I'm going to use another web app. Their marketing department told them that they would net $75,000 a month in additional profit for every 1 second in performance improvement. I immediately offered to take a percentage of that in lieu of payment for a daily rate. They said no, but over the course of 2 days, we dropped this 9 seconds down to a quarter of a second, 0.24 seconds average query result. I don't know if they actually got $75,000 a month times 8 3/4, but they were very, very happy, and they recommended us to all of their friends. Another one is a very, very large organization. They own about 30% of the pest control business in the US and a good chunk of Canada and South America. You can guess what kind of things they had on their walls. You don't go and look too closely at what they have mounted. Anyway, as part of a longer engagement, they said, hey, Jeff, we have these customer service reps, the ones who are going to the homes and spraying them. 3,000 of them are downloading their schedules on a nightly basis, and it's taking 30 minutes plus, occasionally timing out. Taking a look at this one, and one of the questions I was asked was how many days it takes to identify the problem. This one was probably half an hour. We made a change, and this one was a lot of fun because they didn't tell their end users that things were about to get faster because they weren't sure what the end result would be. But I got a call a couple weeks later, and they said, okay, Jeff, so this is what happened. We finally applied the fix. Everybody's response time dropped from 30 plus minutes to under 2 minutes, and every one of 3,000 customer service reps called us to ask if it was broken. I said, oops, sorry about that. And they said, no, this is the best 3,000 calls we've ever received. There's a lot of similar types of case studies there as you, for example, have a call center. If you have 3,000 call center representatives all waiting 8 to 9 seconds to get a result set, then if you can get rid of that 8 to 9 seconds, then you're saving 9 seconds times 3,000 times every single time the person hits enter. So these are very important things to start addressing. So the first step to solving the problem is addressing it, identifying it, and for the sake of discussion, throwing hardware at the problem will be considered masking the problem. And worse, if you mask the problem, what ends up happening generally is that you only mask it for a little while. At some point it comes back and it goes from somebody knocking on your door to the kick of a horse to the head. It hits a lot harder. You spent a lot of money on it and not resolved the problem. Once you identify what you think is the problem, you devise a solution, test the solution, and assuming it works, we roll it out. Testing is very important. I bet you all would have told me that if I hadn't told you that. We do need to decide from the database level, first, do we know what's a database problem? Well, we can identify the performance of specific queries as they occur in the database. Sometimes we can't control it though. I am dealing with a problem actually this morning, today, where the biggest percentage of elapsed time is moving data across the network. Well, if I'm going to move 2 million rows of data across the network, that's simply not going to happen sub-second on most subnets. So sometimes the answer is let's not move 2 million rows, or let's not let somebody move 2 million rows in. That becomes an application design issue. But more specifically, let's ask the question, do we have server-specific bottlenecks? Do we have issues with I/O, insufficient CPU? This, by the way, is something that I look at before a tuning exercise, but don't try to address until after the tuning exercise. If it looks like I/O is an issue, I want to find out what memory is doing. Maybe I have insufficient memory for work, or maybe it's simply that I'm looking at too much information, or the queries are running in an awkward way. Maybe I'm doing a lot of table scans versus a lot of index retrievals. But first I want to know where those bottlenecks are. Then I tune at the micro scale, which is looking at individual queries, looking at indexing, how much data are we bringing back. Once that tuning exercise is completed, I come back and look and ask the question, did I resolve the I/O issue? Did I resolve the CPU issue? And that often happens. Sometimes we go from 80% of CPU down to 10% of CPU. Well, how do we know where the issues are? Well, the best answer is to get yourself a good tool. And we'll look at a tool in a little bit. We'll talk about some of the things to look at. So, hardware. I choose to treat hardware as a mask to the problem, not a resolution. I've been doing this for over 30 years, and 30 years ago, we sometimes had to buy more hardware. Today, what I find is people tend to over-purchase the hardware, and we're running at 5 or 10% of the CPU and still not getting results back. And sometimes it's a bad query, and there's a dozen different things that could be depending on what it is you're actually taking a look at. Server config sometimes is an issue. Server config particularly comes into play in things like VMware environments where people will sometimes overconfigure a box. They'll simply not put enough memory to the CPU or give enough memory to individual VMware slices, not realizing that SQL Server can be a memory hog, especially as you get lots and lots of users. Sometimes we end up rewriting queries, adding indexes, and by the way, it used to be that I would add indexes on a per query basis. Now I do them more on a wholesale basis. It's one of the first things I do when I walk in instead of one of the last. Most DBMSs these days have tools that tell you what their engine tuning advisor thinks are the missing indexes. You can look at those, eliminate the duplicates because there's often a lot of duplication there, and apply maybe a third of the indexes that it recommends and suddenly look like a genius when your CPU drops by 2/3 and your performance increases by a factor of 5 to 10. And dozens of smaller things can fix the performance problem once you're able to take a look at what's causing the performance issue. So, recommendations: take a close look at what the operating system indicators are. Just because your tool is telling you that the query has I/O issues does not mean that you have an I/O issue. It may mean that simply you are trying to bring a lot of data back in. In a Windows environment, and today most folks at least have some Windows environment, I like to look at the OS disk queue length. I really don't care about disk speeds at this point. I don't care about write speeds. I don't care about read speeds. What I care about is, can we get the information off the disk at the rate we're requesting it? So, according to Microsoft, a disk queue length of 2 for a period of 10 minutes is a bottleneck. Well, we're seeing here that we're seeing disk queue lengths exceed 200 for a decent amount of time. So, at least during that time period, we were experiencing a bottleneck. Now, after looking at that, I will take a look at the I/O speeds and ask the question, how fast are we running? What kind of disk are we running? Today, I still see a lot of people running on nimble type devices. I still see people running on spinning disk type of devices. And when you're taking a look at things like that, you do need to ask the question, is this fast enough? How do I tell that? For some real rough numbers, what we'll find is that if you have disk retrieval and write speeds in the 5 millisecond range, you probably have a fast spinning disk. 10 millisecond range, a slow spinning disk. 0.5 or lower, you tend to have memory-based or flash drive-based I/O. In between, it depends on how much you spend for your storage. So, disk queue length is a great place to look over time. As we start moving from the hardware to things like queries, It is very useful to be able to find out how often queries are running, how many IOs they're performing. So why do I care about the IO? Once I bring the data up into memory, memory operations are extremely fast. In fact, it's hard to measure how fast they're running because the results come back so quickly. You frequently get the results back between machine ticks. However, if I measure the amount of time it takes to bring a page in or get to a page, it takes a finite amount of time to identify the page if it's in memory. It takes a larger finite amount of time to identify a page on the disk. So when I'm tuning, I tend to look at the logical read requests in order to determine how busy a query is, as opposed to the other types of activity it's performing. I also take a look at the number of executions we're running. So in this example, I'm running 34,000 executions an hour, and I'm performing about 26 million IOs. Is this number high? It's really not horrible. You're talking a few thousand IOs per execution. But if you can take a 1 second activity and take it down to 0.1 seconds, you're in really good shape. Sanjeev, I'm seeing your question and I will get to it at the end. Thank you for asking it. The other piece of execution volume is when you're performing a huge amount of IO and a small amount of executions. If this is a one-off query, we tend not to want to bother adding an index, unless that one-off query is something that's being performed by, your CEO or your direct boss or his or her direct boss, and that person is not known for his or her patience. So overall, we're trying to look at root cause. We're trying to find out emphasis, and we're trying to hit the low-hanging fruit first, finish a tuning exercise, and then get in there. Summary: tune first, buy hardware second. Now I want to come to Sanjeev's question. In your earlier slide, you had mentioned about some fixes for performance tuning. Amongst them were smaller things. My question is what we should consider smaller things: indexes, stronger CPU, more memory, etc. Sure. So first I'm going to eliminate hardware because that was what I was talking about eliminating. Hardware is kind of a big thing. Of the other things that you've listed, indexes are the first place I go. That has many aspects. First is what indexes are missing. Let's go and apply the missing index. Second, how much duplication do I have? How over-indexed am I? And do I have a lot of indexes that are unused? The over-indexing of tables can have a major effect on I/O because every time you insert a row, you also have to update all the index structures. You delete a row, update all the index structures. Update a row. Well, if the row moves, you're updating all the index structures. But also with indexes, you need to make sure the indexes are maintained. They need to be defragmented. You need statistics kept up to date. So the components of indexes and data defragmentation, which I'm lumping in there, I would consider those certainly smaller things, but those are high on my hit list. Disk types, not high on my hit list unless I'm I/O driven. Database version, not too high on my hit list unless I'm seeing some inconsistency. One of the things that I will look at when I'm going in for a performance gig is to find out whether the most up-to-date patches on the software. So I walked into an organization yesterday and they're running SQL 2016. Well, SQL 2016 is running the end of its life cycle this summer. So if any of you are running 2016, you probably want to stop running 2016 at some point in the near future and upgrade that. But when I look at it, I want to find out if they're that old or they're running the most recent patches or not. So yes, database version, not so much in terms of the version you're running, but whether you are current from a patching position, because there are always lots of performance bugs that get fixed. Sanjeev, if you have more specific questions, please ask. I have a question from Nadir. Please comment on some performance degradation issue noted after a database software upgrade. Oh, that's a favorite thing for people to hate. So I've seen this on a number of occasions. So when you update a a software, the database software, this is generally a major upgrade type of thing. You're going from 2012 to 2017 or to 2019, as opposed to applying a patch. What ends up happening is with each release of the server, the optimizer gets a little smarter, and then every once in a while, Microsoft engineers decide they're going to completely rewrite the optimizer. So from a practical perspective, you may end up with a completely different type of query plan that wasn't available before, and it may just be that you have a version where that's not working too well. So what do you do about it? Well, first you analyze both, and then you go back to some of the basics, because a lot of the times when you have a performance change, it's because something did not completely update, or you're missing something like specs. So for example, you may have statistics pages that hadn't been updated lately, and if the statistics had been updated lately, the change might not have caused the problem. So when somebody reports that problem, I'll ask, have you updated your stats? Have you rebuilt your indexes? Have you reorged your indexes? Is all of your maintenance current? Have you done that since the upgrade? The other thing that I've found as an unusual gotcha is sometimes when you upgrade, the plans that you have for stored procedures were stored in such a way that the optimizer is unable to take best advantage of the query tree that's been placed on disk. So when I'm experiencing a lot of that, one of the other things I will do is to try dropping and recreating all the stored procedures. I have found that to be effective. And then the final thing you need to do, sometimes there's just a bug that's been introduced in the new version of the software, and you have to go in and take a look at the query. Now, what I have found is it tends to be the overly complex queries where that tends to be a problem as opposed to the simple ones. And sometimes what you need to do is bring that query to somebody who does a lot of refactoring and say, is there a better way of writing this query? It just does not seem to be performing well. If you're performing poorly on one version, it's generally going to perform poorly on the next. And if it degrades some, then it might be time to refactor the query. Was that more than you wanted to hear on that one? I don't know. If you have a more specific question, please jump right in. All right. Other questions on performance before I dive into master data management? Cool. All right, so master data management. Here's the idea behind master data management. When I first was introduced to master data management, it was at an organization that does patient and medical billing for hospitals. So what basically happens is this. The hospital sends patient and care information to this middle tier, this vendor. The vendor sends the information out to the insurance carriers. The insurance carriers pay the claims, and those claims are paid from this middle tier out to the hospital. Why would they do that? All the insurance carriers have different ways they want information presented. All of the hospitals hate dealing with the continuous changes on the parts of the insurance vendors, but they do want to get paid. So they pay a tiny percentage to the middleman. The insurance carriers pay a tiny percentage to the middleman. And when you're dealing with billions of dollars a day in premiums and payments, this becomes a lucrative business. But here's the thing. Think of all the components and all the types of data that they're dealing with. They have all of the diagnostic codes, all of the medical codes, all of the pharmaceutical codes, all of the you name it, that the insurance company requires. There is some standardization now, but that hasn't always been the case. On the flip side, you've got the hospitals that are treating people, and they have to uniquely identify the individuals. Is this an individual we've treated before? Is this something that we have brought into our environment? I've got 3 hospitals that are related to one another and 2 that are not. Do we have individuals who are in a drug-seeking behavior at one of the three that we are working with, but then going to another one which we do not own and trying to perform the same thing. Is this something that the insurance carrier cares about? Is this even going through insurance? So all of this information, the unique identification of the patient, the unique identification of the care, the unique identification of the carrier, the unique identification of the service, the unique identification of whether it is a covered service. This is only part of it, because you've also got, on the part of the middleman, you've got the sales perspective. Okay, I've just made a sale and now this hospital is coming into the fold. Okay, I've just made another sale and now this insurance carrier is coming into the fold. So then this hospital has to be brought in and addressed to all the insurance carriers that we're dealing with, and vice versa. So this is a complex master data management problem. And honestly, the more complex, the more fun. I'm a database geek, right? But as you start looking at these problems, the need to answer this becomes absolutely critical. So, simple identification at a large company. You've got financial systems, CRM systems, transactional systems, archiving systems. They're all running in separate environments, sometimes separate DBMSs. You may have something running in Oracle Financials, something else running in SQL Server, something else running software as a service at a different vendor site, something else in QuickBooks, something else in you name it. When you have all of these things, you're frequently trying to figure out how to get the data together. And a lot of folks have processes involved where they perform extracts. Everything goes into a data warehouse. The data warehouse is kept up to date on a periodic basis from each of these sources. So you've got this, you were hanging on by your fingernails, you finally have a solution, you put it in place, and then the powers that be acquire one of your competitors and you're taking all of their problems and dropping it into yours. So once that happens, everything gets fun again. So how do you make sure that when you get this type of thing, the customer information in one environment actually makes it to another environment? This is master data management. MDM defines the process of collecting the enterprise data, applying your rules, and these are rules that you set, building a single view of the data, and distributing this golden version to all the various systems. So let's make note of this because there's a couple of really important points in here. Point number one, you need to define what this master data is. And you need to define what the results are going to be and what people are seeing and how it goes around. Buying a master data management system is barely the first step. You need to do a lot of analysis and a lot of definition. Next, this moves in multiple directions. So if you have a change from your CRM system, maybe your customer was acquired and now it is now known by the name of the parent company, and all the billing goes to the parent company, all the accounting goes to the parent company, all the mail goes to the parent company. That needs to make it from your CRM system to your financial system to your, you name it, whatever these components are. And another thing that you need to define is, okay, if I change it in financials, does it get updated automatically in CRM? And vice versa. What if I update it in both places and it starts cycling and going back and forth? You have to take this problem and resolve it. We do have people who kind of spend their lives now dealing with the master data management issue and identifying where the pulls come, where the pushes from, and what the individual components look like. This is a common problem today in mid to large size businesses. Small businesses in the $50 to $100 million range, not generally, but honestly, that first time I got brought into it was a $50 to $100 million business. So, is this a problem? A very large percentage of decision makers are saying that not being able to figure that out is causing them a problem. An awfully large percent of it are also saying that they feel their organizations have suffered long-term damage. Long-term damage defined as increased operating costs. And by the way, that snowballs. Productivity and efficiency. internal productivity and internal efficiency are one of those awful little cancers that hit companies. And when those start to snowball, people start leaving. So not only do you lose productivity and have to start training new people, but you end up losing a lot of your mind share and a lot of your experience when those things head out. Lack of agility obvious, and ability to compete. It says inability to complete. It should say inability to compete. Just want to make sure that what you're saying is still what you should be saying. Beautiful. So, some of the questions that you need to ask. Where is your data? How old is your data? Is it still relevant? At a company that I was referencing earlier, they were keeping 20 years of patient data online. Why was that? The owner of the company said, at some point, somebody's going to want to buy this historical information and be able to answer the question, based on this treatment plan, which ones were most successful and how many people were coming back for more treatment, things like that. Is it up to date? Who has access? Here's a really important one. What is your retention period? Of the customers we have, I would say fully 10% of our customers right now are working on projects for archiving older data. You know what the first step is? Defining how long you can keep it. Yeah, I like this, Sanjeev. Thank you. At the moment of the MDM, you ask, what is your crown jewel? What is the most important thing to you to keep? And I will come to topics like that as well. Anyway, so do we have compliance issues with this? What are the data components? Where can this data sit? Do I have regulatory reasons where I have to keep the information in-house, or can I push it up to a cloud? Can I use a hybrid model? Azure in particular, and the most recent version of SQL Server, let you keep your database on-prem and use Stretch in order to take some of the data, automatically push it up to the cloud, have it sit there on the cloud, but still be accessible as if it is on-prem data. Very cool tools. One of the things that you need to do is build your specs. So, using master data management, and by the way, there are multiple tools out there for master data management. We don't necessarily push any of them. Microsoft has one that for a long time was included with SQL Server. I don't know if it still is. I'm not a licensing guy. I'm a database guy. But that's the one I am the most familiar with. So use the metadata, classify your data, put policies together, and automate what you've got going on. So as you start looking at something like an ERP system, you frequently deal with a number of commonalities. So a customer master, and once again, your customer master may not be the most important or the most volatile or the toughest one to deal with. So the customer master for the organization that I described earlier, you've got the customers of that middleman, who are the hospitals and the insurance companies, but you also have those patient records, which may or may not be more critical, but those absolutely have to be treated as master data. Item master, account master. Master data is a critical company asset. I have seen companies be acquired for the purpose of acquiring master data, and I've also seen companies acquired for the purpose of using their IT systems. I've seen smaller companies being brought in so that the bigger company can absorb the application that is running the company of the smaller company. By the way, when that happens, you get to charge a premium for your company and smirk all the way to the bank. A lot of different master data types. We've got unstructured. Are you saying master data are the same as the critical data elements for a company? Not necessarily. The master data are more the common elements across the individual systems for a company, but they do tend to be absolutely critical to the functioning of a company. Master data types include unstructured data, transactional data, metadata, the data about the data. Metadata is one of the ones that will sometimes trip you up more than you expect. So for example, in one system, brown, B-R-O-W-N, in another system, brown, B-R-W-N, in another system, it's the number 4, in another system, it might correspond with a color on the spectrum. So beware of that one biting you. Hierarchical data, this one gets interesting. Historically, hierarchical data was always a challenge to work with, and I've got multiple clients who have had to deal with that in very interesting ways in the past. Today, a lot of the DBMSs have hierarchical data types, which dramatically simplify that. Reference data, other types of master data. Here are a list of some master data domains, customers, products, locations. And keep in mind that when you say customer, customer might have multiple meanings. Same thing with products, locations, and we get to pretty much everything else. The master data architecture is multiple tier, typically 3-tier. And within the scope of this 3-tier system, we have that central MDS database, the master data system, the master data warehouse, the master data repository. And that's what contains the information on the master data. But it also contains the metadata about where it's pushing to and pulling from. That's absolutely critical. You also have, as part of that master data service, the ability to automatically generate or regenerate the targets and sources based on your definitions and the definitions that you want to create. In a typical master data repository, you may find that information is going in multiple directions to and from multiple sources, and those sources may have multiple sources. So this is a diagram I was able to borrow from a real customer that had built this and put this together for their senior IT executives to explain to the non-IT executives exactly what was going to go on. Directions the data is moving, the directions that the data is going to be fresh, the update frequency, does it need to be real time, what systems needed to be real time, etc. Now, I have frequently dealt with companies where I've walked in and they said, Jeff, you are sort of walking into not a trap is not the right word, but a minefield is the right word, because we've already tried this master data thing twice. Both projects spent way over budget and both of them were absolute failures. And when you walk into that environment, one of the first things that you want to do is come in and Sanjeev, I promise I'll get to all your questions. They're all good questions. One of the things you want to address early is let's take a small portion of the work. Don't try to do all of it, but take something small, make that your proof of concept, get it working, because then the other components tend to fold in much better, much more easily. So pick the things that you care about, let the rest of it sit for a while. Note that when I say just one thing, that doesn't necessarily mean just one thing, but a small subset of all the master data. So take that small subset, complete the integration, get the data loaded, add your new data types and push it out. Make sure that you're not trying to boil the ocean. Boiling the ocean is very expensive and tends to bother the fish. There's a variety of different types of master data. I've only got about 10 minutes left. I'm not going to spend a huge amount of time going through the theoretical stuff, but for those of you who want a copy of this presentation, simply reach out and ask, and you'll have it here with you. Behavioral describes the way it works. Life cycle describes what types of modifications can be made to it. Cardinality defines whether you're likely to call it master data. If you have only 3 customer types, is this something which is going to change a lot, or is this something that you need to move around? You typically don't have to build push and pull decisions around things that have no cardinality. How long does this information last? What is the level of complexity? Is this something where we don't really need to go through that? but what we really need to do is just track how much we've got. How valuable is the information? And the value of the information is not necessarily just to the organization, but it's also what is the value of this from a long-term perspective, giving us the ability to later perhaps resell the data or a portion of the data or a masked version of the data. Great example of that, a very, very large insurance company put together a master data project to gather the information for all of the treatments that it was running against all of its patients across all of the vendors across the entire US. They built a Mongo project on top of that to start asking questions, which treatments were better and under which circumstances. Very cool information in there to be able to bring out. Master data, we try to bring the less volatile information in because you don't want that to go absolutely crazy. Master data is typically reused. If it's not going to be reused, it probably does not need to go into the repository. Here is an end of section case study on master data, and it's a pretty easy one. The idea here is that when a credit card customer moves, he is going to notify his credit card company that he moved. So does this go into the billing system? Does this go into the receivable system? Does this go into a customer record? Does this go into a calling record? Do we have to track these things historically? When the customer calls and says, hey, I've moved, the company may go ahead and change the address, but it may not go in everywhere. What if that address goes in incorrectly? So instead of 1001 11th Street, it goes to 101 11th Street. As we are trying to interact with the customer and get paid, the customer starts calling his lawyer because he says, hey, 3 months ago, I called and gave them my change of address. Here's the date. They never sent me a bill. Now they've turned me over to collections. So as you start looking at things that initially sound simple and you start talking about the distribution and the organization of the data, and you start talking about where this central truth resides, we start seeing that not only does it have an impact on us, our costs, our attorneys, our internal people trying to track it, but we lose customers, and the cost of customer acquisition today, speaking as a business owner, is high. So at this point, I'm going to answer whatever the remaining questions were on master data management, and I'm going to turn the session over to anybody who wants to ask questions. So, what was the VPS in the earlier diagram? That was a point of sale system that the customer had. Kind words from a friend and more kind words from a friend. So hopefully, I think I've answered all the questions. We've been awarding gift certificates to people who participate. I am going to award one to Sanjeev and one to Nadir. Thank you both for asking useful and relevant questions. I will get what we've been doing is sending out Amazon gift certificates. Hopefully you find those all interesting. At this point, I'm simply going to thank you all for showing up. If there's anything in here you found interesting, I appreciate it. We will be getting this presentation loaded to our YouTube channel. If there's anything in here that you'd like help with or your organization is struggling with, we'd be very happy to get involved. Please reach out to us. My name is Jeff Garbus, and I appreciate you all spending this past hour or so with me.